Right, good day and welcome. Welcome back to Maths and Physics from Mr. Simons. Here we're looking at application of calculus exam questions, and we're specifically looking at November 2016 rates of change. Right, so let's look at the question. November 2016, they say the number of molecules of a certain drug in the bloodstream T hours after it has been taken is represented by the equation MT equal negative t cubed plus 3t squared plus 72t, right? T is greater than 0 and less than 10 there, all right? So for 1.1, they say determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken, all right? So we want the number of molecules by bloodstream 3 hours. So technically all you're saying is this T will become 3 hours, and we're going to substitute it wherever we see T. Right, so MT equal minus T cubed plus 3T plus 72T, and we have 3 hours. So M3 equal minus 3 cubed plus 3 times 3 squared plus 72 times 3. At 72, 10, 216, that would give me 9 plus 3, 27, 27 minus 27 cancels, so I have 216 molecules in my bloodstream, right? So that gives me 216, right? Look at the next question. Determine the rate at which the number of molecules of the drug in the bloodstream is changing at exactly 2 hours after the drug was taken. So whenever we see the word rate, that's why it's called rates of change. Rate means I have to find first derivative, right? And they're changing at exactly 2 hours. So in the first derivative, I'm going to place 2 hours. So, right, equation we have MT equal minus T cubed plus 3T squared plus 72T, right? As I said, because of rate, I'm going to find first derivative. So F prime T, 3 times negative 1, negative 3T squared. 2 times 3 gives me 6t plus 1 times 72 is 72, and then the t falls away. So there's my first derivative, 3 times negative 1, negative 3, t squared. 2 times 3 gives me 6, and then 1 times 72, 72, but the t falls away. Right, so we want exactly 2 hours, so we're going to put in 2 in the place of t here. So m prime 2 equal minus 3 2 squared plus 6 times 2 plus 72. 72 plus 12 would give me 84. 84 minus, let's see, 12. That would give me 72. All right. So the rate at which the number of molecules in the bloodstream is changing is 72 molecules per hour. So every hour, my bloodstream is actually absorbing 72 molecules of that tablet that I've drank, right? Or drug as they call it in this problem. Right? Now, 1.3, how many hours after taking the drug will the rate? So when I see the word rate, first derivative, to which the number of molecules of the drug in the bloodstream is changing, be a maximum. So for it to be a maximum, I'm saying the first derivative, I'm going to have to derive again and make it equal to 0. Right, so rate, if I said maximum rate, it simply would have meant first derivative equal to 0. But rate and maximum are not written next to each other, so first derivative, second derivative, right? So mt equal minus t cubed plus 3t squared plus 72t, that was given to us. Find first derivative first. 3 times negative 1, negative 3, 3 minus 1, 2, 2 times 3, 6, 2 minus 1, 1. 1 times 72, 72. Because of maximum, I'm going to find the second derivative. So that will become 2 times negative 3, negative 6t plus 6. Right, so there. 2 times negative 3 gives me negative 6. 2 minus 1, 1. 1 times 6, 6. 1 minus 1, 0. Anything to the power 0 is 1, so that t falls away. Right, because they said maximum, minus 6t plus 6 must equal 0. Right, and from there, if I take negative 60 over, it will become positive 60. So I have 60 equals 6, and then 6 divided by 6 would give me time equal to 1. Right, so how many hours will the rate at which the number changing be a maximum after 1 hour. It would reach the maximum, and in this case it would have been 72 molecules per hour. That's the maximum that my bloodstream is able to absorb at a time. Right, so I hope you follow, I hope you understand how I've done the rates of change. Continue practicing. Your effort will be rewarded. Alright, God always rewards hard work. Alright, God bless. Bye.